Okay, we're on problem number 4, and this is exercise 69. And I'm reading it. It's, difference of cubes of the two numbers, 316. And after a product of the numbers be added to the sum of the squares, the sum is 79. Find the numbers. So again, I would say read it, write down what you have. But what I really mean is you really want to get a piece of paper and pencil out to see if you can do this. So what I want to do is I want to go back and I'm going to I got the document in front of me now. I'm going to read it again. And I'm not memorizing what I've read, but I want to point out in number 4, let me write this over here for you. We're still looking for two numbers. This is so typical of this problem set. So these, X and Y are numbers. I just don't know what the numbers are. And what does it say? It says the difference of their cubes. So let me write this down. So I'm going to write down X cubed minus Y cubed. And they said the difference of the cube is 316, all right? I'm going to keep reading it, and it says, if the product of the numbers be added to the sum of their squares. What's the product of the numbers? X, Y. And they want it to be added to the sum of their squares. And again, I'm just reading through a few words at a time. It says if I do that, I would get a sum of 79. So, the bottom line is I have another system of nonlinear equations, and someone says, what are you going to do now? I'm going to try to solve it. And when I say I'm going to try to solve it, I get stuck sometimes. I can't do things, right? Or it gets so complicated, I just can't get there, all right? So what I want to do is just look at it and start to realize that maybe I could try things, including dead ends, all right? So I'm going to look at the first equation, and I'm going to factor it. And what would that be? X, it's the difference of perfect cubes, by the way, Y. And then what would you get? You'd get x squared plus xy plus y squared. And that would equal 316. Now, by doing that, you might say, oh, this is just, it's too good to be true. Maybe it is. Maybe it is too good to be true. But what I notice now is I know x squared plus y squared plus xy is 79. So what do I know? I know x minus y times 79 is equal to 316. All right? And you know what? Another thing that might be too good to be true, maybe both sides are divisible by 79. And you'd get x minus y. Well, maybe not, by the way. But I'm going to say 4, because 4 times 70 is 280. And 4 times 9 is 36. Yeah, looks pretty good. All right, so someone says, what are you going to do now? Well, I guess I'm going to solve that for y. And what would you get? X minus 4 is equal to y. So what am I going to do now? I'm going to take this. I'm going to plug it into this one over here. And let's see what we come up with. And what do you get? You're going to get x squared plus x minus 4 squared plus x times y now, right? What's it going to be? X times x minus 4, and that's going to equal to 79. Oops, that wouldn't be good. Let me go backwards. 79, right? And so what I'm going to do now is I'm going to try to solve it. And to do that, I guess I got to simplify it a little bit, right? So x squared plus x squared minus 8x plus 16 plus x squared minus 4x equals 79. And I know what somebody said, this is ever going to end. It will end if you move forward. So what do you get over here? You get 3x squared, right? 1, 2, 3. And what do you get over here? It looks like minus 12x. And let's see, I got to take 79 from both sides. So it's going to be 63, right? It looks like it's divisible by 3. It's just really nice. So I'm going to divide both sides by 3. What do you get? X squared minus 4x. And again, don't be discouraged if you're trouble. One thing nice about video, you can always pause these tapes and say, I want to finish it out myself. And, look at the answer key. You can stop looking at these videos anytime you want. And what do you get over here? 21. And I'm going to say this looks pretty simple to solve. And that would be 7 and 3. Minus 7 plus 3. So x would equal minus 3. and the other answer x could be 7, all right? So again, I'm not going to say that's the answer to their question. Their question is, what are the numbers x and y? Well, I know what x is. So I want to go back, original problem, and I realize I got something over here that's pretty simple. And what is it going to be? X minus 4 equals y. I'll write this over here. X minus 4 equals y. So what did you get over here? Y in this case over here would be minus 7. And y in this case over here would be 3. So I have two ordered pairs, minus 3, minus 7, and the other pair is going to be 7, 3. All right? Now, by the way, you know, what I normally do at problems is, I'm glad I got to the end of it, but it would sure be nice if you could, you know, reread the problem again and see if it makes any sense to you. And that's fine. You can reread the problem, see if it makes sense to you. The other one to recommend to you is that we do give you a picture. It's figure, at least in the notes I'm looking at, it's figure 192, and that's on page 1228. I would strongly recommend looking at the picture of it. And the reason for that is so you can start to realize there's a relationship between a visualization of a problem and the actual problem itself. All right. So, you know, looking at it, you know, is a very interesting looking graph, by the way, but I do see those 2 points of intersection. And what points you're looking at, the points we say they're there. All right. So again, I hope this is, I can't say it's entertaining, but I hope it's helpful to you. I really do hope it's helpful. Thank you so much for paying attention.